Assalamualaikum and hi everyone. My name is Nun binti Muhammad Noor. You can call me Madam Nun. In this video, I will discuss first topic which is about the physical quantities and measurement. In this topic, there are three subtopic. The first subtopic is dimension of the physical quantities. The second subtopic is scalar and vectors. And the third subtopic is significant figures and uncertainties analysis. For the first subtopic, which is dimension of the physical quantities, there are three objectives. The first objective is you will define the dimension. The second objective is you will determine the dimension of the derived quantities. And the third objective is you will verify the homogeneity of the equation using the dimensional analysis. Okay, now take a look at the definition of the dimension. So dimension is defined as a technique or method which the physical quantity can be expressed in terms of combination of the basic quantities. So we use the symbol of bracket to represent the dimension. So how we use it? We can write down the physical quantity inside the bracket, full name, or you can use the symbol. So here I give you few example how we use the symbol for the dimension. So this table shows the dimension of the basic quantities because of we want to express the derived quantities in terms of in terms of basic quantity. So you need to know the dimension of the basic quantity. So if you look at the basic quantity, there are 7 basic quantity you have learned before. So the dimension for mass is represented by the symbol or capital letters of M. For the length, capital letters of L. And for the dimension of time is T. Dimension for the electric current is I. The dimension for the temperature, which is theta. Dimension for the amount of substance is N. And the dimension for the luminous intensity or luminosity is C. So referring to this dimension symbol, we can derive the dimension for the derived quantity. So to determine the dimension of the derived quantities, we will use the dimensional analysis, which is a method to investigate the relationship between the different physical quantities by identifying their base quantity and unit of measurement. So this dimension analysis can be used to determine the unit of the derived quantities and also to check the correctness of an equation using the principle of homogeneity. So what is principle of homogeneity? So principle of homogeneity state that the dimension of all terms on both sides of an equation is the same. So, and we have another terms, very important terms, when we want to apply the principle of homogeneity, is the dimensionless quantity. So, dimensionless quantity is the quantity that do not have dimension because of that quantity no unit or the value and the value is equal to 1. Instead of the dimensionless quantity, we also have the number. So for the numbers, there is no dimension, so the value is equal to 1. Same with the dimensionless quantity. So here I give you few example, which is we have the refractive index. Okay, refractive index, the dimension of refractive index is equal to 1 because of there is no refractive index, no dimension, right? And then if you have in an equation a number, for example number 2, we can refer to the equation of kinematic equation, which is v square is equal to u square plus 2as. So the number 2 inside the equation, the value for the dimension is equal to 1. Same thing with the half. The dimension half is equal to, the value for the dimension of half is equal to 1. So you can refer to the equation of kinetic energy, which is equal to half mv square. So the number half, the dimension is equal to 1. Okay, next we will verify the homogeneity of the equation using the dimensional analysis. So homogeneity means the equation is dimensionally homogeneous or dimensionally correct. So before we can verify the homogeneity of the equation. So there are few basic rule that we need to follow. We can follow so that we can identify we can verify the homogeneity. So the first basic rule is if we have the equation involve the additional and subtraction. So the way we write, for example here, I give, let's say the equation is A equal to B plus D minus E. So the way we write down the dimension equation is the dimension for A is equal to dimension for B equal to dimension for D and equal to dimension for E, meaning that the additional or subtraction operation, the dimension for the terms is equal. Okay, for the second basic rule, if we have the equation such as A which is equal to BC over D, meaning that this is multiplication and division operation. So for this rule, the way we write down the dimension is as shown, where the dimension of A is equal to the dimension of B times with dimension of C divided by dimension of D. And the third rules is the combination between the additional or subtraction with the multiplication or division operation. So we have here the equation of A which is equal to B plus C square over D. So the way we write down the dimension equation is the dimension for A is equal to the dimension for B, and equal to, because of this is additional operation, equal to dimension of C square divided by dimension of D. So this is very important for us if we want to verify the homogeneity of the equation. Okay, now take a look at the example. Okay, the first example. We need to determine the dimension and the SI unit for the following quantities. Okay, here there are velocity, linear momentum and kinetic energy. So how we use the dimension analysis to determine the dimension and also the SI unit? Okay, take a look at the solution. Okay, for the velocity, first identify the equation for velocity. So because we know that the velocity is the derived quantity, so the equation is equal to displacement over time, or S over T. So when we have the equation, we can write down in the form of dimension equation, where dimension for V is equal to dimension for S divided by dimension for T. And because of just now you learned about the dimension of the basic quantity, for example for the displacement or represent the length S, so the dimension of displacement is L and the dimension of time is T. So because of that, we get the dimension for the velocity is equal to LT minus 1. So when you get the dimension, you can identify the SI unit for the velocity, which is M, which represent the L, and S minus 1 represent the T minus 1. Okay? Now take a look at the B, which is the linear momentum. So how we identify the dimension and SI unit? Okay, first, you know the equation for the momentum, which is equal to mv. So we write down the dimension equation. The dimension for P is equal to the dimension for M times with the dimension for V. And please, when you write down in the bracket form for the dimension, when you write down the symbol for dimension, no need to use that bracket. We just, to differentiate between the two physical quantity, we just use the symbol of parenthesis. Okay, so M represent the dimension for mass, dimension for velocity. Here we know that the dimension for velocity is LT minus 1. We just substitute and then we get the dimension for the linear momentum, which is equal to MLT minus 1. Because of that, the SI unit for the linear momentum is kgm s minus 1. How about the kinetic energy? So, the way we identify the dimension and SI unit is refer to the equation of kinetic energy, which is equal to half mv square. So, we write down the dimension equation. So, here there are a number which is half. So, because of just now you know that the number half, the value for the dimension is equal to 1. So we just replace 1, and the dimension for m, which is mass, is m, capital letters of m, and the dimension of velocity is LT minus 1. And do take note that the velocity have square there, so you need to square the dimension too. Okay, so when you solve this, you will get that the dimension for the kinetic energy is equal to ml square t minus 2. Okay, and the SI unit is kgm square s minus 2. Okay, that's the way how we identify the SI unit and the dimension for the physics quantity. Okay, now take a look at the second example. So for the second example, you need to show that the dimension of the equation of V equal to U plus AT is homogeneous. So how we want to show the homogeneity of the equation? So there are three steps. This is my suggestion. Three steps. Okay, the first step is you need to write down the dimension equation. So referring to the equation given, the dimension equation is dimension for V is equal to dimension for U equal to dimension for A times with dimension for T. So why we use equal? Because of this is additional operation. Remember, if the additional operation or subtraction, the terms are in the equation, the dimension for each term in the equation is equal. Okay, after we get the dimension for the equation, to show the homogeneity, okay, you need to use the technique which is, this is the symbol for dimension for the left hand side. So LHS represent the left hand side of the equation, and the RHS is represent the right hand side of the equation. So referring to the dimension of the left hand side of the equation, where we have the velocity here, the dimension of the velocity is LT minus 1. And then at the right hand side, we have two terms, which is U and AT. So the dimension for U, which is U is initial velocity, so the dimension is equal to velocity LT minus 1. And for the A, dimension for acceleration times time, okay, it is equal to LT minus 2 represent the dimension for acceleration, and T is represent the time. So you will get the dimension for A times T is LT minus 1. And now we will compare between the left hand side of the equation, the dimension at the left hand side, and the dimension at the right hand side. And if you check each side, each term, they have the same dimension. So we said that the dimension at the left hand side of the equation is equal to the dimension at the right hand side of the equation. So it is a step 3, meaning that you mention that the dimension on both sides of the equation are the same. Because of that, the equation is dimensionally correct, or the equation is homogeneous. Okay, so that's the way how we show. We use the dimensional analysis using the left hand side and right hand side technique. Okay, now we go to example 3. Okay, referring to the question, the equation P is equal to AG rho V. Describe the variation of the pressure P with the gravitational acceleration G, density rho, and velocity V of a liquid which flows in a horizontal pipe. So if A, here is A, so if A is dimensionless constant, determine the homogeneity of the equation. So to find the homogeneity of the equation, either we want to check the dimension of this equation is correct or not. So we follow these three steps. Okay, the first step is, as usual, we write down the dimension equation. And referring to the equation given, because of AG rho V is the multiplication operation, so our dimension equation is as shown. Okay, next step, what we need to do? So we will use the dimension analysis, which is we refer to the left hand side of the equation, dimension at the left hand side, and also dimension at the right hand side. So for the dimension at the left hand side, because of this is pressure, so you need to remember the derived quantity, which is pressure. The equation is F over A. So you write down the dimension equation, and then write down the dimension symbol, represent each term inside the equation, and then you will get the dimension at the left hand side, which is equal to ml minus 1 t minus 2. Okay, referring to this dimension for each physics quantity here. Okay, at the right hand side, because of we have A, G, rho, and V, so we will do it like this. A, because stated that A is dimensionless constant, so it is equal to 1. For the G, G is gravitational acceleration, the dimension is LT minus 2. For the rho, rho is the density, density is mass per unit volume, so the dimension for the mass per unit volume is ml minus 3, and the dimension for velocity v is lt minus 1. So we differentiate the dimension for each term using the parenthesis symbol. Okay, and then when you solve all these dimension, you will get that it is equal to the dimension at the right hand side of the equation is equal to ml minus 1 t minus 3. Okay, now you compare with the left hand side equation, the dimension at the left hand side. We compare with the dimension at the right hand side. If you look at that, right hand side is ml minus 1 t minus 2, but at the right hand side is ml minus 1 t minus 3, meaning that the dimension at the left hand side is not equal to the dimension at the right hand side. Because of that, we can say that the dimension of the equation is not homogeneous, because of you need to identify, right, the homogeneity of the equation. So because of both is not equal, the dimension at both sides is not equal, so we say that the dimension of this equation is not homogeneous. Okay, so I hope that that's it for this time in this video. So I hope that you know what is the dimension, and then you know how to identify the dimension and SI unit from the dimension analysis, and you know this three step to identify the homogeneity of the equation, or to verify the homogeneity of the equation. So that's it for today's video. I hope that you always take care of yourself, and good luck in everything. Thank you very much, and Assalamualaikum. Thank you for watching. Don't forget to subscribe my channel Cikgu Nun and watch my other videos.